coming with another video, that is power supply. In this video we'll discuss about the power supply. First of all, we'll see what is power supply and its sample definition. Power supply is an electrical device that provides the necessary voltage and current to power electrical circuits. That means it gives power to the electrical components or circuits. It converts alternating current into the direct current. Here is the circuit diagram of power supply. It is having bridge rectifier, voltage regulators, capacitor, LED, resistor, diodes, everything. We'll see what is bridge rectifier. In this, we'll see the sample definition of bridge rectifier. Bridge rectifier can combine 4 diodes arranged in a bridge configuration. It converts AC voltage into DC voltage. Diodes can flow current only in one direction. Here is the sample representation of bridge rectifier. 4 diodes is combined in a bridge configuration. It converts alternating current into the direct current. Here we see. It converts AC to DC. There is a representation. And next we will see what is voltage regulator in the next slide. And we will see we are having 2 voltage regulators. One is 7812 and another one is 7805. First we will see the definition of 7812. 7812 voltage regulator means it gives output voltage 12 volts and it belongs to the 78 series voltage regulators. That means it gives only 12 volts output voltage. 7812 voltage regulator gives 12 volts output voltage. In the input will give 14.5 volts to 35 volts, but in the output will give 12 volts only. And next we'll see about the usage of 7812 voltage regulator. Basically we use this 7812 voltage regulator to provide the output voltage 12 volts. It is having 3 pins. One is input, output, and the third one is ground. We'll see how it will look like. This is the representation of voltage regulator. It is having 3 pins. First pin is input, second pin is ground, third pin is output. This is the representation of the 7812 voltage regulator. We can connect pin 1 input and pin 3 output. And in this we'll explain about 7805 voltage regulator. This 7805 voltage regulator, in the output it gives 5 volts only, but comes to 7812 voltage regulator, it gives output voltage 12 volts in the output, but 7805 it gives 5 volts only. It also belongs to the 78 series of linear voltage regulators, same as also 7805 as 7812. In the input we give 7 volts to 35 volts, but the output we receive 5 volts only. And next we'll see. Now we will see power supply in the Proteus software. Actually Proteus software is used for software simulation purpose. In this we'll go with the new project. Actually the Proteus software is downloaded from the Google Chrome. After that it will look like this. First of all, for new project we have to give a new title to the project file, and then we have to choose where it should be saved in the path. We'll give the name to the project and we have to save in a particular path, either in documents, downloads, wherever we want. Then click on the next button. After that next button we have to go with do not create a PCB layout, and then create next, and then we click on finish button. After creating a new project, this is how it looks like, a blank page. This is used for software simulation. And here in the left side we see P and L. P indicates parts. First of all we have to search for bridge rectifier. Bridge rectifier is 2W0050. This is bridge rectifier in the Proteus software. We have to find this in the parts. After finding, we will click on OK. Next 7805 regulator, voltage regulator, we will click on this. This is how it indicates in the parts. Then click on OK. Then it will be added to the PL parts. Next 7812 regulator. What are the components we are needed to build a PCB? We can add all these components into these devices. Here in the lecture we can see bridge rectifier 7805, 7812. RES means resistor, CAP means capacitor. We will find capacitor also. And next, this capacitor also added to these devices. Next in the part we will search for battery. We will take battery also for the power supply building. Battery is also added to the devices. And then next we will search for a red LED. Red LED is also we find. Red LED is also added to the devices. This is how we can add what are the parts or components needed to build a power supply. We can add these particular devices to this PCB. First of all, we have to take the bridge rectifier. Bridge rectifier means we are also known. Bridge rectifier is a combination of 4 diodes. There are 4 diodes. And next we take 12 volts battery we also found. Next 7805 voltage regulator, 7812 voltage regulator we also find. This is 7805, 7812. Next 7805 regulators, 2 both regulators we are also added into this 5. Next 7805 regulator also we added. Then we will see how we connect each and every component in this software. Next we add capacitor. Here also known capacitor is used to store the energy. And then next red LED, capacitor, red LED, resistor also we have to add. Red LED is also added to these 5. There we have to connect battery positive to the bridge rectifier one end and battery negative to the bridge rectifier another end. One end to the bridge rectifier of battery positive and another end to the bridge rectifier end. This is how we connect the bridge rectifier to the battery. Next we'll connect bridge rectifier one end to the 7812 voltage regulator and another end to the ground. This is how we connect. And we'll connect the bridge rectifier 7812 to the 7805 also. And next we'll connect the another end to the ground, same as like 7812. Both 7805, 7812, both regulators should be connected to the bridge rectifier one end and the another end is connected to the grounds also. Next we'll click on the resistor and next red LED also. We have to rotate the resistor. Next we'll connect the resistor to the red LED. We have to connect LED positive to the resistor one end. We have to take the resistor that should be 180 ohms. We have to click on resistor, how much the resistor is, 180 ohms resistor. We have to connect the red LED positive to the resistor. We'll connect one end of resistor to the bridge rectifier and another end to the ground. This is how we connect a resistor and LED to the bridge rectifier and ground, and next we connect the capacitor to the bridge rectifier one end, and another how we connect capacitor one end to the bridge rectifier and another end to the ground. This is how it looks like. And next we have to add the ground to all these 7812, 7805 bridge recti. We have to connect ground to that all the components. There we find the ground. We add the ground to all the components. That means we have to connect it. This is how we connect. Next we have to add DC voltmeter to see how much voltage should be provided at 7812 and 7805 regulators. How much voltage should be generated. We will check by using DC voltmeter. We can connect the DC voltmeter to 7812 output one side and one side to the ground, and next like that we have connect 7805 output to the voltmeter, and next we have to connect ground to the another side. This is how we connect a DC voltmeter to 7812 and 7805 regulators to see how much voltage should be generated in the outputs of both regulators. That means we have to check it. Generator in the 7812 it is near to 9 volts. We see 7805 it will be 5 volts, and 7812 it will be near to 9 volts. We can observe. This is how it will be generated the output like this from these two regulators, and red LED will be also on. We can check there. The red LED will be on. If you off the simulation, the LED will be off. If you run it, the LED will be on. Run, that means LED will be on. That is the indication. It get the power to the power supply board. This is how it works for us. From the 12 volts battery, we can get the power, AC power, and the bridge rectifier can convert it into DC. Now for AC we use B side. We can include B side. One end is connected to the bridge rectifier positive. This is for AC powers, and another one is for DC. You can use both AC and 12 volts battery also. In this project we use 12 volts battery for simulation. For the 12 volts battery we can use AC for DC purpose only. For generating DC current we can use AC or 12 volts battery. If you run the 12 volts it will be provided 7812 voltage regulator provides near to 9 volts. For 24 volts it should be provided correctly 9 volts at 7812 voltage regulator. For 24 volts it should correctly provide 12 volts. For 12 volts it should provide 9 volts at 7812. We see for 24 volts it should be 12 volts correctly generated. For 12 volts it should be 12 volts at the battery should be provided near to 9 volts. This is the software simulation of